Hello everybody, welcome back. I hope everyone's doing well. Um, Lots of work going on with the Jaguar in terms of the wiring harness and trying to figure out how to do the different sensors that are on there, how to get them into the MS3 system, how to modify the MS3 to handle the transmission adapter with the CAN bus and everything. Um, I've kind of designed a notional wiring harness, and we'll get to that here shortly, and started installing that into the Jaguar. We're mostly done with the wiring harness at this point, but I do have to install the O2 sensors, and that requires me to start building the rest of the exhaust, right? So we're building a 2¼ inch exhaust out from the manifolds, the factory manifolds that are on the Jaguar. So to do that, I need to start cutting some steel, tacking and welding all that stuff in there, and install O2 bungs for the wideband sensors. We haven't done any of that work yet. We're getting there. That will be hopefully starting up in the next week or two. But I do have a notional idea of what I'm going to do with the wiring harness, and we'll go over that here shortly and kind of show what we did in the vehicle. I've also been doing just a lot of reading on what the diagrams from the Jaguar look like and what they look like in the MS3, and trying to integrate everything together, and also doing things like studying like the GM transmission, right? How do you tune that thing, right? What are the different sensors doing in the car, right? So just a lot of studying and that kind of stuff just eats your time up in learning all these concepts of how to do the MS3 appropriately, and make sure we're not going to damage the engine, right? Because the last thing we want to do is have a system that's as unreliable as the original Jaguar was. I mean, this thing only has 36,000 miles on it, right? So there's a reason it only has 36,000 miles on it. It never ran right. And we want to get away from that and put more miles on it and not have to tow it home every other time we drive. So without further ado, here is kind of the notional wiring stuff that we're doing. So this is the current design I have for the MS3 main board connector. So this is the lower connector on the MS3 system. One thing you'll notice here is I have a 160 tooth crank sensor. That's the VR sensor that's on the flywheel. This is standard with the Jaguar XJS. And then this here, this 1 tooth crank sensor, this is the front sensor that's normally a 3-tooth sensor, but I removed 1 tooth and had the rest of it balanced. So we're going to use a 160 to 1 tooth crank sensor. The other thing we're adding is a data log switch here on this side. Otherwise, this is pretty much standard MS3 hardware diagram stuff included within the hardware manual. The one thing that the MS3 system does mention is the 100 and the whatever plus whatever type tooth is not very defined. Not a lot of people use it, so there is going to be a little bit of experimentation involved with that, but this is what I have that got me to where I'm at right now, and I think it's going to work. Worst case scenario, we will modify this crank sensor with a traditional 60 minus 2 tooth or something like that. But we'll see what happens as we get closer to firing up. So this is the MS3 Extra board. This is the upper connector on the MS3. This, again, pretty much follows the standard MS3 hardware configuration. These coil drivers here, these are AEM3 coil drivers, right? So these are available. I actually got these from Summit. And here's where your coolant B hooks up. The other thing that we did do is we left in the 6-kilo ohm connector that you would normally find in your Jaguar. Now this was because I'm not quite sure how the rest of the resistance within the tachometer is situated. So from your tack pin, so from let's see here, this pin 26, right, tack out, that's going to do a 12-volt signal, right? And it's going to go through a 6.K ohm resistor, and it's going to go into tack pin 3 of the black connector that's in the engine bay. Now, I don't know what's beyond here within the instrument cluster, so I don't know if this 6.K ohm is some kind of resistance that is required to give us a 5-volt signal for the tack, right? I just don't know. I haven't really investigated much what's in the tack circuit itself, so I left that in there because normally this would be a 12-volt signal that's coming from your primary coil, right? So it is the 12-volt from the Jaguar XJS. It goes 12 volts into a 6.K ohm and then into your tack. Now this could be a very large resistance in here. If it's close to like a mega ohm or something, which is not an uncommon resistance, you would see a 12-volt signal there. So you could get away with just using this 12-volt out from the tack out here as is and be perfectly fine. I just wanted to double down and do what the Jaguar itself is doing and make sure that our tack works appropriately. We'll find out down the road. But up here you'll see some of the modifications that we did to the typical system that would be found on the MS3 hardware diagram. And nothing really crazy out of the ordinary. Again, we are using a MS3 compatible transmission controller. So we're going to have a manual transgear lever here and a manual on-off switch. So we can go into a manual mode. And if we go to the section where we go over what that is, this is your transmission interface. You have CAN high, CAN low, ground, your solenoid power, and your controller power, right? So this CAN high and CAN low is what's going to control us on what we're doing with the actual controller, right? So all this stuff here and all of this is all communicated through the CAN high, CAN low bus, right? So one other thing that the one thing that's interesting about how to control this manually, and they kind of touch it in the manual for the transmission controller that we have, but if you look at the software setup, there's a setting for a horn, right? So you would normally have in some of these older vehicles, you have a horn that can be either pushed on the left or pushed on the right, and then you push it in the middle, right? So pushing on the left and the right gives two different connections, and pushing in the center pushes both the left and the right connector. Or you might have seen some of the old steering wheels where there's a button on the left and a button on the right. So in this diagram in the actual hardware manual, they talk about, and then in the MS3 Tuner Studio setup, they talk about a horn output, but that's only if you're using this in conjunction with the buttons that are on the steering wheel. So if you push your left horn, you would go up or down, and then you push the right horn, you would go up or down, and then you would push both horns to actually honk the horn, right? So that's what that is talking about. But for us, we don't have this set up on a horn system. So we just need to use a voltage divider to tell the system to go up or down. So for us, we're going to take 5 volts. Now you can use a 12-volt source. You could also use you can always use this directly from your car source, like your 12 volts from your alternator. But I didn't really want to trust that because sometimes the alternator dies and you're at 12 volts and not 14 volts. Sometimes the alternator varies, and I didn't want any variation in this voltage. I wanted a nice constant voltage, and I know that the MS3 5 volts for the throttle position sensor is going to give me a nice consistent voltage that I can actually rely on to give me the voltages for up and down as needed. So this is the circuit that I'm using here, 1K ohm initially to reduce your current. And then you'll just either get 0 volts for a downshift or 2.8 volts for an upshift based on this circuit dividing circuit. Nothing exciting, and that's how that will work. So basically everything's wired up, and for this system we're going from the front of the engine to the rear of the engine. Any wiring harnesses that came off the front, like the AC system, that's all been shifted to go to the back of the engine. I haven't hooked anything officially in yet because I'm just waiting to get the test firing. Then we'll get them all mounted in. But basically everything's coming from the front of the engine, come to the back of the engine, along the firewall here, and then goes into the original holes. There's a couple of harnesses that I made here, 2 different harnesses. There's one harness that goes through here, and the other harness comes through the sidewall here where it originally did. Those are the 2 original harness holes in the firewall. This was for the this was for the ignition, and this one was for the fuel injection system. So we're just reutilizing the holes for that. And we have the ignition coil drivers wired up here. The ignition coils are down in the V. All in all, once everything gets kind of tucked away and you won't really see it, I think this is going to be a pretty clean install. As far as the Mega Squirt transmission control unit goes, that install is right here, and you've seen that in previous videos, but here it is actually wired into the vehicle. So this harness, it's hard to see. Let's see if I can get mine down there. This harness right here is what connects to the system, and this is where it integrates into the rest of the vehicle. So that comes up, and then I installed a inline fuse there because there was not one previously, and I like to have things fused, but it basically comes into the, this is where it gets its power. So this would have originally powered the ignition ECU, so we are now using it to power the transmission ECU. And then the CAN bus cabling comes in this same comes down through here, and that connects into that pin down there that you see there. So the CAN bus is wired up. Pretty much everything that you need to do is done in terms of routing wires and building cables and all that stuff, but the only thing we have not done yet is the oxygen sensors need to get installed, but I need to start building an exhaust for that, so that's a little bit of work. I can't do that this week. The hope is to get it in the next week or 2, but again, that's a whole nother part of the build, so it's going to be a little while before that actually happens. But once I get O2 sensors in here, and we'll put in the belts. We'll finish wiring up loose connectors that are original from the vehicle, right? So some of these things are not powered up, but that's fine. We're gonna do as minimal amount of connections as possible for the test fire, just to make sure it rolls over and ignites, and then we'll go ahead and install everything else. But that's it. Well, that's it for today. I hope this video is helpful for everybody. If not, they're helpful for me to just kind of walk myself through and talk out loud on what I'm doing and how I'm modifying things. So worst case scenario, I reinforce what I've learned by hopefully giving you guys information. Have a good day.